Okay. Well, welcome everyone. Thank you for those of you who were on with us early and were bearing with us there. My name is Sarah. I'm the Senior Events and Program Specialist here at Global, and it's a pleasure to be with you today. While we're giving folks a few more minutes to get logged on, we'll go over just a few upcoming dates that we'd like to share with you all. First and foremost, our Be Beautiful, Be Yourself fashion show is back this year on Saturday, November 16th at the Sheraton Denver Downtown Hotel. Please visit our website to get more information to buy tickets for this wonderful event. Our next global webinar will be on Tuesday, January 14th, 2025. And it will be covering cardiac health in Down syndrome with Dr. Arvind Hoskapal. Lastly, our annual acceptability gala will take place on Wednesday, May 21st, 2025 in Washington, D.C. Before we start, just a few housekeeping items. The webinar today is 1 hour and 15 minutes long, and during the last 15 minutes, we will be doing questions and answers with Dr. Espinosa. If there are lots of questions and we have people still logged on, we will extend that by about 10 minutes. While we do have lots of pre-submitted questions, you can continue to ask more questions via the Q&A function at the bottom of your screen. While we may not be able to get to all of them today, please know that we will get all of the questions answered and endeavor to get those up on our website in about 3 to 4 weeks. As you know, Global's quarterly webinar series is one of the benefits associated with Global's membership, which start at just $20 a year. Thank you again for supporting Global and our important research and medical care work. We will kick off the webinar now with a brief welcome introduction from Marielle Carrillo, an amazing Global advocate and supporter.
Thank you and welcome. Thank you to Global and everyone attending today a webinar. My name is Maria Carrillo, and I am so happy to be here today, presenting Global. And I am 29 years old, and I live with my mom and dad in Greeley. I have been involved with Global for about 15 years now. I have spoken at the Ability Gala, a president at the Conference of Model and the Beautiful Be Yourself a fashion show. A little bit about me. I love to dance and sing and go to a concerts. I always like to look my best. So I do my own makeup every day and always have to have my nails done. I enjoy spending time with my family, talking to my friends on the phone. I volunteer with my aunt, who is a teacher at yeah, at maintenance, helping kids read and with other activities. Today we will cover stopping the immune attack and the Down syndrome, new breakthroughs, and clinical trials with Dr. Joaquin Espinosa. Now I went to Institute's Brand Solano, the Vice President of Research and Medical Care at Global.
Thank you, Marielle. That was wonderful. That was a great introduction, and welcome everyone to our quarterly global webinar series. We're excited to share that we've had over 520 people register for today's webinar, representing 17 different countries, 17 different countries and 42 states. We have especially big showings from California, Colorado, Maryland, New York, Ohio, Texas, and Virginia. We also have over 20 local Down syndrome organizations represented today, so welcome. And while everyone in our audience is a superstar at Global, we must call out our amazing 9 self-advocates in attendance today: Nicole A., James A., David E., Eric L., Sarah M., Catherine R., Brianna R., Julia S., and Mel T. Thank you so much for joining us. For those of you who are new to Global, we're part of a group of affiliates under one umbrella that include the Cernic Institute for Down Syndrome and the Alzheimer's and Cognition Center, leading the world in Down syndrome research, the C Center for Down Syndrome at Children's Hospital Colorado, and a pilot adult Down syndrome clinic with Denver Health. Our goal is simple: to elongate life and improve health outcomes for children and adults with Down syndrome. Today, we are fortunate to have with us Dr. Joaquin Espinosa, who will be covering stopping the autoimmune attack in Down syndrome, new breakthroughs in clinical trials. Dr. Espinosa is the Executive Director of the Linda Cernic Institute for Down Syndrome and Professor of Pharmacology at the University of Colorado School of Medicine. Dr. Espinosa directs a diverse research program with emphasis on Down syndrome that's supported by the NIH Include project and the Global Down Syndrome Foundation. At the Cernic Institute, Dr. Espinosa directs the Human Trisomy Project, a detailed natural history study of the population with Down syndrome, which has enabled the design of novel clinical trials to improve health outcomes in Down syndrome. Dr. Espinosa currently serves as the leader of the Administrative and Outreach Core of the NIH Include Project Data Coordinating Center. It's a new data resource that aims to accelerate discoveries into mechanisms underlying the increased risk of co-occurring medical conditions in people with Down syndrome. And now, please help me welcome Dr. Espinosa.
Thank you, Brain. Thank you, Marielle, for the introduction. And thank you to the Global Down Syndrome Foundation for giving me an opportunity to bring to the community an update on the latest in the realm of research into the immune system in Down syndrome. Let me find the right slide here to share, and we'll get going. Very good. And as Mariela Breen mentioned, I'm the director of the Linda Cernic Institute for Down syndrome. And for those of you who are not familiar with this institute, it is home at the University of Colorado Anschutz Medical Campus here in the Denver area. And it has become the largest center for Down syndrome research in the world. More than 60 research teams studying different aspects of the condition. We have lost count by now how many scientists at the University of Colorado are studying Down syndrome, but we estimate more than 200 by now. And since 2012, this group of scientists and physicians have published more than 200 scientific publications, all of them working together with the goal of serving people with Down syndrome through advanced biomedical research, leading to improved medical care. And I think one of the reasons that we have been able to attract so many researchers is this concept that people with Down syndrome have a different clinical risk profile. So what do we mean by that? We mean that, it's the first time in history where there's a sizable population of adults with Down syndrome, where we can now study hundreds, if not thousands, of medical records and monitor the frequency, the prevalence of various co-occurring conditions. And when you do that, you learn that individuals with Down syndrome, very strikingly, are protected from some medical conditions that are very common in the general population. For example, it's very rare to hear of an adult woman with Down syndrome having breast cancer, or an adult man having prostate cancer. Those are the most common cancer types in the general population. Very rare to hear of adults with Down syndrome being affected by atherosclerosis, hypertension, leading to myocardial infarction or heart attacks, as you would call them. Now, unfortunately, on the other hand, individuals with Down syndrome have higher risk, higher prevalence of a number of co-occurring conditions. We'll talk today quite a bit about autoimmunity, but this is also true for Alzheimer's disease, which occurs earlier and is significantly more common in adults with Down syndrome, leukemias, COVID-19, and many other lung respiratory infections, early in life, RSV virus, later in life, COVID-19, but also pneumonia. And of course, there are many other conditions that are more likely to be observed in people with Down syndrome. So I think that for the longest time, the field has focused on the common but variable traits, the stunted growth, the neurodevelopmental delays, the early aging, and that's fine. We need to study these traits. But it's also becoming more apparent that if we want to help people with Down syndrome live longer, healthier lives, we need to address these current conditions that are more common in this population. So from a scientific standpoint, what we need to find out is how that extra copy of chromosome 21, which is one of the smallest chromosomes in the human genome, how does that extra copy of that small piece of DNA is causing all these developmental and clinical features. And we know that there's about 200 genes. To give you a sense, if you look at the entire set of chromosomes, there's probably about 20,000 genes, give or take, depending on how you count. So there's only 200 genes on chromosome 21. It's a finite, small number. We should be able to find out which of these genes, when triplicated, going from 2 copies to 3 copies, are causing the undesired effects of trisomy 21. And then if we knew what genes are causing this or that feature, perhaps we can come up with strategies to counteract the detrimental effect of gene overdose. Now, with all that being said, we also need to acknowledge that everyone with Down syndrome is very unique. Every individual with Down syndrome is dealing with that extra chromosome 21 in their very personal way. And yes, some of them may have many of those core conditions that I just mentioned. Some of them may have none. And even the common traits, what we call the common traits, for example, the cognitive differences could be very, very variable, right? And, you have individuals here like Sujit, who plays 7 musical instruments very well in front of large audiences. You have my friend Frank Stevens, who's very articulate and very, very passionate, and he can give these great speeches, in front of large audiences. But we may have other participants in this slide that are perhaps nonverbal or have a dual diagnosis of autism or are impaired by a number of co-occurring conditions. So clearly we need to study a lot of people with Down syndrome. This diversity is not a problem. This is an opportunity for discoveries. We need to embrace this heterogeneity. So with that in mind, in 2016, here at the Shrinick Institute, in partnership with the Global Down Syndrome Foundation, we launched the Human Trisom Project. This is a large and diverse cohort study, meaning a study of hundreds of individuals with Down syndrome with deep annotation of their clinical data, biobank with different types of samples, and public research portals. So every year, we've been recruiting several hundred participants. We are right now at 1,300 or so. And then from each participant, we obtain those clinical histories, and then we use those blood samples or other biological samples to derive these various molecular and cellular data sets, like the genomes, the transcriptomes, and other things that the scientists want to use to make discoveries that may help people with Down syndrome. So this foundational study has supported many studies, more than 40 different projects, leading to many publications. And the story that I want to tell you today is about one discovery where the first publication out of a series of publications came out in 2016, and in a very short amount of time, this led to a clinical trial that just finished. And as you will learn today, that now has led to a second trial and a third trial. So these scientific advances are happening in our lives. You know, it's not like the research of today will take 100 years to produce tangible applications. Within a few years, it is possible to apply discoveries made in the lab into clinical trials that are testing new medicines, hopefully benefiting people with Down syndrome. And the key observation from the Human Trisom Project that I want to bring to your attention is this notion that there's widespread autoimmunity in Down syndrome. What is this? When you look at hundreds of medical records of people with Down syndrome and compare them to medical records of people without Down syndrome, you see that people with Down syndrome are more likely to have one or more so-called autoimmune conditions. More than 60% of adults with Down syndrome have at least one autoimmune condition. The most common is autoimmune thyroid disease. This can manifest as hyper or hypothyroidism, meaning too much or too little activity of the thyroid gland. The most common version of it is hypothyroidism. Now we know that more than 35% of adults with Down syndrome have been diagnosed with one or more autoimmune skin conditions. This could be alopecia areata, autoimmune hair loss, atopic dermatitis, or sometimes referred to as eczema, hidradenitis suppurativa, sometimes confused with folliculitis or the boils, as we call it, vitiligo, you know, those clear patches in the skin, psoriasis, characterized by those plaques, you know, those lesions in the skin. Then we have celiac disease, around 10%. I think this is an underestimate. It's very hard to diagnose celiac disease properly. And that is tenfold more than in the general population. In the general population, celiac disease is about 1%. Okay. And there are other conditions in the single digits that are also more common in Down syndrome. This pie chart shows you the overlap in these conditions. So out of 278 adults that we study with in detail, 18 years of age or older, only 25% we couldn't detect an autoimmune condition. 35% had one, 23.9% had two, 10% had three, 5% had four. So oftentimes we meet individuals with Down syndrome that have 3, 4 autoimmune conditions. And I would like to put the notion up there that this may be the tip of the iceberg. These are the conditions that we're looking for, the conditions that we know how to recognize them. But the immune system is acting everywhere in the human body 24/7 through our lifespan. So I would like to put it out there that we need to be open-minded about the presence of other clinical features of Down syndrome that may be related to this autoimmune phenotype, this autoimmune trait. And now imagine for a moment that you saw this data and you didn't know that the participants in this study had Down syndrome. You didn't know. You were blinded to that. You will look at this and be like, wow, this is a syndrome of multi-organ autoimmunity of pediatric onset. What I'm not showing you today is that most of these conditions, 80% or so, are diagnosed in the first 2 decades of life, during pediatric age. Right? So if you didn't know that this was trisomy 21, you'll be like, wow, this is multi-organ autoimmunity of pediatric onset syndrome. So what is going on here? Well, the immune system, which we all have, and again, is in all organs across all tissues, is there to protect us from the non-self, from the pathogens. This could be viruses, bacteria, parasites, other stuff that doesn't belong, right? So that's on a good day, the immune system is recognizing the self and leaving it alone and focusing its attack on the non-self, on the pathogens. But on a bad day, on a scenario of autoimmunity, the immune system becomes confused and loses the capacity to protect the self and starts attacking the self. So it starts attacking the thyroid gland, you get hypothyroidism, starts attacking your hair follicles, you get alopecia areata, it starts attacking your gut, you get celiac disease and so on and so forth. Okay. So we like to say that by these criteria, Down syndrome should be considered as an immune disorder. And sometimes we face resistance when we say that. But I want to pause here for a moment and elaborate on this concept. Of course, we say that Down syndrome is a chromosomal abnormality. Nobody would challenge that because that's the foundational event, right? That extra copy of chromosome 21, everything comes from that initial event. But we have no issue saying that Down syndrome is a form of intellectual developmental disability. Why do we say that? Because if you take hundreds of people with Down syndrome and perform some cognitive tests or some measures of development, you see some differences. So nobody argues with this concept, right? Well, but the same criteria, if you look at the immune system of people with Down syndrome, you see a lot of dysregulation, a lot of changes, a lot of autoimmune conditions. So by that operational definition, it is safe to say that Down syndrome is also an immune disorder. And I should point out that the National Institutes of Allergy and Infectious Diseases, NIAID, the largest funder of research in the immune system in the world, recognizes Down syndrome as an inborn error of immunity. So this is not just me telling you that Down syndrome is an immune disorder. This is the top experts, the top agencies coming to an agreement that we can understand Down syndrome in good measure, not exclusively, but in good measure as an immune disorder. So what is going on? Why would people with Down syndrome have an immune system that is making these mistakes? Well, here's the short version of it. People with Down syndrome have what is called hyperactive interferon signaling. So this is an aspect of the immune system that we use to fight off viruses. The immune system has many branches. You can think of the immune system as the armed forces. You have the Army, the Coast Guard, the Navy, the Air Force. There are many branches to it. Well, the interferon response is the branch that fights off viruses. So when a cell is infected with a virus, that cell releases these molecules known as interferons, which then bind to receptors, these green antennas on neighboring cells, including immune cells. And through this binding of the interferons to the receptors, a cascade is triggered that launches a defense, right, against the virus. You can think of the interference, if you will, as the alarm system, saying, hey, there's a virus here. We need to do something about this. Now, we know that too much interferon signaling could be a risk factor for autoimmunity. It can get the immune system closer to making a mistake. So why do people with Down syndrome have more interferon signaling? The most parsimonious explanation is that because interferon receptors are encoded on chromosome 21. So let me explain this for a moment. I told you the interferons are these molecules, these small molecules that signal the presence of the virus from the infected cell to the neighboring cells. Now, the signaling needs to occur through these receptors. And when the interferon binds to the receptor dimerizes, meaning two molecules of the receptor come together, and that joining of the receptors triggers a set of biochemical reactions inside the cells, what we call JAK-STAT signaling. This is the jargon for what's happening inside the cell. And that JAK-STAT signaling is what then triggers the immune response. So people with Down syndrome, it turns out, they don't make more interferons. They have more of the receptors, right? So given a fixed amount of interferons, they are more sensitive to it because they have more of the antennas, more of the receptors. So this is like if you're trying to capture, a signal, and you have an antenna that is yay big, you're gonna be able to detect the signal.
But I'll go in there after 10.
I think there is I'm gonna mute there, our colleagues at the global team. So if you have a big antenna or have more antennas, you're gonna be hypersensitive to any signals that are being produced. So this interferon receptor overdose is not good, right? It leads to an overreaction throughout the immune system. When a person with Down syndrome is fighting a virus or is having an immune reaction, they overdo it. They're more likely to have complications. This overdrive can cause the immune system to make mistakes. And then over time, you can think of this chronic hyperactivity leading to exhaustion of the immune system. And we know that older adults with Down syndrome have weakened immune systems, especially weakened lung immunity. So too much of a good thing in this case is definitely not good. And I would like to share some data. You know, don't take my word for it. Look at the data. This is a very simple graph. In this graph, I'm showing you here data from the Human Trisom Project. There are 96 participants. I would say they have the control karyotypes. These are volunteers from the general population that agreed to be part of the Human Trisom Project. In green, we have participants with Down syndrome. Every dot is a participant. And what we're plotting here is the interferon score. This is a blood test that we do where we measure the amount of interferon activity. And as you can see, on average, the mean increase is 13-fold on average. People with Down syndrome have 13 times more interferon activity than the general population. Now, with that being said, you can also appreciate there's a wide range of activity. So there are some individuals with Down syndrome that are in the normal range of interferon activity. There are some that are 50, 60 times hyperactive. Remarkable. These are a lot of immune activity. To give you a sense of a scale, I'm showing you here on the right, the same metric, the interferon scores, for people in the general population without and with COVID-19. No Down syndrome, COVID-19. Look at the scale. The scale is the same, right? From 0 to 40. So the blood of people with Down syndrome by this metric looks like the blood of a person in the hospital with COVID-19. This is remarkable. This is a lot of immune activity that we're talking about. Somehow, people with Down syndrome manage to go about their lives with this much immune activity in their system. Remarkable. So seeing this, then the question is, well, can we do something about it? Would drugs that decrease the interferon response improve the health of persons with Down syndrome? And this is where, with the scientists and people with Down syndrome and the physicians, we all got very lucky, because it turns out that the pharmaceutical industry has developed a class of medicines known as JAK inhibitors, and not for Down syndrome, but for a range of autoimmune inflammatory conditions listed here on this table. So there are many of these. This table is not complete. There are more than just these 5. It seems like every week or every other week there's a new JAK inhibitor. They have different drug names, different brand names, and various approvals. So if you see a plus symbol, it means that it is approved for that condition. For example, rheumatoid arthritis, there are multiple JAK inhibitors approved for that. And then when it says JAK1, JAK1, 2, well, there's more than one JAK enzyme. So that's why you see JAK1, JAK1, 2, 3, that kind of thing. So these medicines are used by many different doctors, rheumatologists, of course, for rheumatoid arthritis, psoriatic arthritis, or juvenile idiopathic arthritis. Dermatologists, now we have some of these JAK inhibitors approved for atopic dermatitis, alopecia areata. Hematologists, you know, for conditions such as polycythemia vera, and more, right? So the question now is, well, could these JAK inhibitors normalize the immune system in Down syndrome? So let's talk about this medicine. These are small molecules that get packed into a pill, or it could be an oral solution as well. And you take this twice a day or once a day, depending on which brand. And then this gets into your system through your blood in every organ and every tissue. And then these molecules go inside the cell and block these enzymes, the JAK enzymes, that sense activation of the interferon receptors, okay? So people with Down syndrome still will produce interferons, and they will still have the extra chromosome and have more of the receptors. But now, with this medicine, we can tone down that immune activity. Something that I really like about these medicines is that they are fully reversible. The half-life is a few hours. So if you take a medicine 9 a.m., by noon, only half of it is on your system. By 4 p.m., only 25% of is in your system. By night, it's less than 10% in your system. That's why, to get the full effect, you need to take it twice a day, in the morning and at night. So that's good, because if there's a side effect or there's an adverse reaction, you can stop. And within a couple of days, you know, there's nothing in your system. Where other medicines, that turn down the immune system, they last a lot longer. Some of them stay in your system for months. So it's a bigger commitment when you use those other medicines. So with this in mind, we launched the first clinical trial for JAK inhibition in Down syndrome. And we focus on the autoimmune skin conditions. You say, well, why didn't you focus on the thyroid disease? Well, because the thyroid disease could be managed fairly well with hormone supplementation. Right? But we learned talking to the families and talking to the physicians that these autoimmune skin conditions are very hard to treat here in Down syndrome. Alopecia areata, so this is the immune system attacking the hair follicles and then the hair falls off. Hidradenitis suppurativa, I should say this is a mild case. You know, sometimes we see big lesions, you know, that get infected with bacterial infections. They can be very painful. They could be multiple parts of the body. Atopic dermatitis or eczema, psoriasis, is plaques in the skin. And then vitiligo, this is when the immune system attacks the pigment producing cells and you start losing pigmentation. You get these white patches. Again, all of them are more common in that syndrome. More than 35% of adults have had at least one of these. So the clinical trial is 4 to 9 months of treatment with an FDA-approved JAK inhibitor gel shots, which is approved not for the skin conditions. It's approved for rheumatoid arthritis. But again, because of the science of it, we thought, oh, this might be a good idea for the autoimmune skin conditions in Down syndrome. And this trial that has finished activities was funded by the NIH, the National Institutes of Health, through the INCLUDE project. So here's the study objectives and design: individuals ages 12 to 50. This was open label. Everybody received the medicine. And we were able to travel to cover a lot of the travel and lodging expenses. So 4 goals. First of all, safety profile. You would say, well, why do the safety profile? Aren't these FDA-approved medicines? They are. But chances are there was nobody with Down syndrome in those clinical trials that led to the approvals. So we felt that we needed to assess the safety profile again to determine the impact of the immune markers on the immune skin conditions. And then why not, since we're doing this, why not take a look at cognition and quality of life? So the key questions, you know, is this a safe approach? Is it effective? And what are all the possible benefits of normalizing the immune system? So the trial finished activity a couple of weeks ago. The goal was 40 participants. We had a couple more. We overshoot a little bit. And what this graph is showing you about, first of all, the qualifying skin condition. Half of our participants had alopecia areata. Half had hidradenitis suppurativa, the balls. A few have both. And then we have a couple cases of psoriasis. But what I want to highlight here with these green boxes is all the other conditions that the participants have, right? When you're doing a clinical trial in the population with Down syndrome, you have to acknowledge that it's a population that has medical complexity, where, you know, 50% or more are going to have thyroid disease. More than 40% are going to have a congenital heart defect. 40% or so may have obstructive sleep apnea. Obesity is more common in Down syndrome, vitamin D deficiency, so on and so forth. Why do I say this? Because when you read the clinical trial protocols in the general population, they exclude everybody with thyroid disease, everybody with a cardiovascular condition, everybody. So people with Down syndrome rarely qualify for those trials that you see in the general population. So it was very important for us to design a trial that is inclusive and that takes into consideration, again, the great complexity in the co-occurring conditions of Down syndrome. And this also informs our monitoring protocols. You know, we know that these participants have some health issues, right? So we need to, when we review the clinical labs, the safety data, we need to keep this in mind, right? So this is a safety data. What is this chart? What is this exposure adjusted event rate? So what we do, we are constantly monitoring every participant and asking them and asking their caregivers, hey, what's going on? Anything that you want to report this week? Oh yeah, I had a runny nose. Oh yeah, I got a skin rash. Oh, I got a little bit of cough. Great. We annotate everything. We have controlled vocabulary. We have a big database. And what I'm showing you here is the most common adverse events, from the most common to the least common. And they are plotted every 100 patient years. So what this means is that if you give this medicine to 100 individuals with Down syndrome for a year each, 100 patient years, this is what you would see. 70 runny noses, 60 skin rashes, 30 events of cough, 25 events of diarrhea over 100 years, 20 cases of vomiting over 100 years, so on and so forth. So this is an acceptable safety profile. This is something that is not alarming in any shape or form. Now, without a placebo arm, it's impossible for us to know if this is more or less than you would have observed if you were not given the medicine, right? So the next trials will have comparison arms so that we can see whether this is more or less. And the other thing to keep in mind that we ran this trial during the COVID-19 pandemic, right? The trial started recruitment in October 2020, and it just finished. So we had a lot of COVID cases, cough, runny noses, that rhinorrhea, that's what it means, runny noses. So we met our safety endpoint. The medicine is deemed safe in people with Down syndrome. Now, with all that being said, I want to tell you the one and only serious adverse event that we observe. What is a serious adverse event? It's something that requires hospitalization, something that requires medical attention, okay? So JAK inhibitors, if you buy a bottle of a JAK inhibitor and you read the label, it says, among other things, increased risk of thrombosis, blood clots. So do contraceptive pills. If you buy contraceptive pills that have estrogen in them and you read the label, it says increased risk of thrombosis. These are things that the FDA puts there on the label. It doesn't prevent the approval of the medicine, but you need to be aware of this. So we have one participant that was taking both our medicine and estrogen-containing contraceptive pills, and this person developed blood clots. So the participant, they let us know, was withdrawn from the study. They stopped, the doctors stopped both medicines, and the participant has since fully recovered and is planning to resume tofacitinib, the JAK inhibitor, and switch now to a progestin-only contraceptive pill. So, there's no good evidence that the two medicines have an adverse reaction, that the two medicines together are more dangerous, but nonetheless, to be on the safe side, we've been advising everyone who needs to take the contraceptive pill to use a progestin-only, non-estrogen type of pill. Just why not, to be safe. So the effects of the skin were very profound. Like everything in Down syndrome, with a range, with inter-individual variability. But look at these numbers. 14 out of 18 of the participants with alopecia saw hair regrowth. 11 of the 19 with the boys with hidradenitis suppurativa saw improvements. Most of the participants with atopic dermatitis, so were cured. This was resolved. 3 or 4 of the participants with psoriasis saw improvements. But this last bullet point is what makes me really happy. That more than 60% of the participants, the benefits were so obvious that the families, the doctors, medical insurance, they pursue a prescription. These are often off-label prescriptions. Remember, the JAK inhibitor that we're using in this trial is not approved for the skin conditions. Families wanted to stay on the medicine. In most cases, they were successful at obtaining an off-label prescription. Here are some examples. You may have seen these pictures in previous presentations that I've done. This is a participant from Texas with autoimmune hair loss, alopecia areata, and you can see, he cannot manage to grow hair within 4 months. Full hair regrowth. So the SALT score, SALT stands for severity of alopecia tool, right? So this is the measurement that we do to assess how much of the scalp is affected. So at baseline, 86% of the scalp was not growing any hair. Within 4 months, the score dropped from 86 to 4, meaning most of the scalp was now growing hair, okay? And this is not the only example. I could give you, many, many pictures, just a couple more here. I like this picture because this a participant who flew all the way from Australia to participate in the trial. She had alopecia totalis. So what this means is no hair anywhere. No hair on the scalp, no eyebrows, no eyelashes, nothing for many, many, many years. And you can see that when we turn down the immune system, with this medicine now, the hair, starts coming back. And this is only at 4 months. If you see her now, she has a lot more hair and other benefits as well. Here's another participant, a young woman from Texas, had very little hair left. And as you can see, now the hair is regrowing, right? Many other examples. Sometimes this is another case of totalis. Sometimes the hair recovers in these patches, right? Some parts of the scalp may recover first than other parts, but very obvious here. Look at absolutely no hair growth. And then when you give the hair follicles a break, they come back. The hair follicles want to produce keratin, want to make hair, they want to come back. So there's really no good reason for anybody with Down syndrome to have untreated alopecia areata. When we started the trial, there were no JAK inhibitors approved for alopecia areata. Last time I checked, there are 2 approved for alopecia areata. If you're below 1 with Down syndrome, if you yourself have alopecia areata, talk to the dermatologist, bring this up to their attention. There are now FDA-approved JAK inhibitors for alopecia areata. Here's an example of a man who was very incapacitated by psoriatic arthritis. So he had the skin lesions that you can see here, but he also had a ton of inflammation in the joints. So he could not come all the way to Denver. He was in Vermont. So we worked with a doctor there, a colleague of ours, and they provided the medicine locally. And you can see the skin, right? Look at those lesions, massive lesions in the abdomen, in the legs, and then within a few months, the lesions are clear. And we hear from the family that this man now is a lot more active. He was using a walker, very incapacitated, but now he's having a more independent lifestyle, getting on the stationary bike, having more mobility as his joints are not so inflamed, right? So then, when the participants were coming to the trial, we were running a battery of tests to assess various domains of brain function. We were looking at working memory and executive function with this test, looking at overall development and vocabulary with this test, looking at what is called hippocampal function. This is the part of the brain that we use for learning and memory. We were looking at episodic and spatial memory with this CANTAB test and the later test. And then we were also measuring effects on motor control, cerebellar function with this test. So the question here is, what is the impact of chronic inflammation on brain function? And if we can turn down the inflammation, would there be any benefits? So we saw improvements in the self-reported measures of positive affect, the positive attitude of the participants, general cognitive function, as well as anxiety and depression scores. This was reported by the families. And then in the lab, using the CANTAB tests, which are done on a tablet, we saw improvements on episodic and spatial memory. Now, I should make very clear that we don't have a placebo arm. So we need to be cautious about these results. And now we have some ideas about what type of comparison group we can use to gain more confidence in these results. But promising, tantalizing, promising. Now, for some participants, the effects were spectacular. So on average, we need to be cautious. But for some participants, we don't need to be cautious because everybody knew that they were doing better, particularly for participants that had a history of Down syndrome regression disorder. And here's one of my favorite participants, female, 28 years old, who had a history of Down syndrome regression disorder. And this is a test for visual motor function, the NEPC2, and there are 2 versions of it, the car and the motorcycle. And the participant is asked to grab a pencil and draw the path of the car, of the motorcycle, without lifting the pen, without spilling over outside of the track. And you can tell that the participant was not fully understanding the task and was obsessed with coloring these boxes, thinking it was a coloring exercise. But at week 16, when the participant was clearly doing better, she fully understood the task, completing a shorter amount of time with no errors. The benefits were so obvious that the neuroimmunologist that was taking care of her decided to write an off-label prescription for the JAK inhibitor. Both the manufacturer, Pfizer, and the medical insurance agreed to pay for it. Again, the benefits were very, very obvious. So this leads me then to Down syndrome regression disorder. What is this? This is a rare but devastating condition characterized by sudden, what we call subacute, onset of catatonia, loss of movement, mutism, loss of speech, depersonalization, the person is not there anymore, loss of ability to perform activities of daily living. Sometimes it can get worse, hallucinations, delusions, aggression. So the science suggests that at least a set of these regression cases could be tied to immune dysregulation affecting the central nervous system, affecting the brain, right? And there are examples of similar situations in the general population, for example, autoimmune encephalitis, where the immune system starts attacking the brain, and a person in the general population regresses, if you will. But and so a couple of weeks ago, we published our first results documenting benefits from JAK inhibition in Down syndrome regression disorder. Now, if you haven't read this article, which made it to the cover of the Washington Post on Mother's Day earlier this year, please read it. It's a wonderful article that illustrates how the moms, the mothers in the community, really didn't stop asking the tough questions, and consulting with a lot of different experts, and bringing many of us together to say, hey, have you met this person? Have you met that person? Can you guys compare notes? So a great story, and I think it's great in the sense that it honors the moms, right? So this, if you read this story, this is the story of how we got to the first clinical trial for Down syndrome regression disorder. So this is also funded by the National Institutes of Health. It's a collaboration with Dr. John Santoro, Children's Hospital LA, Dr. Elise Sanar here at Children's Hospital Colorado, and our investigators here at the Cernic Institute. As I mentioned, also funded by the Include project. So what is this? Now we're getting more ambitious. So we're going to compare 3 medicines now. One of them is going to be a psychiatric medicine, lorazepam, which is a benzodiazepine, and the 2 others will be immune therapies. One of them is called IVIG for intravenous immunoglobulin, and the other one will be the JAK inhibitor. We'll compare the safety profile, compare the efficacy profiles, and then we'll do a lot of mechanistic investigation to understand what exactly is going on. So these 3 medicines are all FDA approved for something else. There's nothing approved for regression, but from the experience in the field, some individuals with regression disorder have benefited from one of these medicines. Again, lorazepam is a benzodiazepine. IVIG is intravenous immunoglobulin. This is an infusion. And tofacitinib is the JAK inhibitor that we've been using. So the beauty of this type of design is that we're not trying to come out with a new medicine. We're trying to repurpose a medicine that is being used a lot in the general population. And participants are randomized. They cannot choose which medicine to go into. But then at the end of the trial, which is 12 weeks, if they want to switch, they can establish medical care with one of our doctors and switch to another one of the medicines. We don't have a placebo control group. We put everybody on at least one medicine. But some participants are delayed in the treatment for 3 months to create a control group, what we call the delayed treatment group for comparison. So why compare the 3 medicines? I mentioned already that there's evidence that all 3 may help some people with Down syndrome, but it's also true that we know now that some people with Down syndrome didn't benefit from one of these medicines. So there's clearly a lot of heterogeneity here in this population. So who would benefit the most from which medicine, right? We need to arrive to a personalized medicine approach for the management of regression. So are there characteristics that could predict a good response to this or that medicine? Are there biomarkers in the blood or in the cerebrospinal fluid that could tell us, hey, this person needs to be on the JAK inhibitor, this person needs to be on the benzodiazepine, okay? And there's a lot of research as part of the clinical trial protocol. We're collecting the blood samples. We're doing deep analysis of those blood samples. Each participant undergoes an extensive battery of various tests. These are highly multidisciplinary team with experts in psychiatry, neurology, psychology, immunology, genetics, and so on. Okay. And we have 2 sites for this trial, one here in Colorado and one in Los Angeles. Ages 8 to 30 years old. This is the age at which we feel comfortable making a diagnosis of regression. Earlier, I would say past 40 years old, it could be a question about whether it's Alzheimer's disease or regression. And earlier than 8 years old may be also harder to adjudicate there is truly regression. So half of the participants in one side, the other half in the other side, divided equally into the 3 arms, 12 weeks, 3 months of treatment with one of these medicines. So I just share with you that our first trial for immune therapies in Down syndrome complete activities will be publishing the results soon, so stay tuned for that. Our second trial, which is focused on regression, is about 1/3 of the way through. We're going to go all the way to 60 participant total. What I want to share with you today is that now we are on to our third trial, a more ambitious trial. So this trial is for the pediatric age, right? For younger children, ages 2 and older. And we realized over the years that it's kind of good to have an acronym for these clinical trials as you start to do many of them. Which trial are we talking about? So we came out with this acronym, Mission 1. We're on a mission to improve the lives of people with Down syndrome. So mission stands for modulating the immune system in Down syndrome for improved outcomes and neurodevelopment. This will be the first of a series of trials, all with the same intent, the same goal, to test the safety and the efficacy of immune modulation early in life. So, as I said, pediatric age, everybody with Down syndrome. Now, here's where we're getting more ambitious. We're not requiring any qualifying co-occurring condition. Anybody with Down syndrome, any kid with Down syndrome is eligible, as long as they pass the safety criteria, right? So it would be the first of the trials, Mission 1, would be 6 months with tofacitinib. Dose by weight, so if you're a small kid, you get less of the medicine. If you're a bigger kid, you get more of the medicine. And we'll use the inclusion and exclusion criteria, meaning the safety assessment, to bring somebody into the trial, as defined in the rheumatology, pediatric rheumatology field. This medicine is approved for kids 2 and older with juvenile arthritis. So one way of saying this is, we will treat kids with Down syndrome like if they had juvenile arthritis, right? So it will, the safety monitoring will be carried over by experts in juvenile arthritis. We'll have now 2 arms, the JAK inhibitor versus nothing, the standard of care. And this first phase of the trial is funded by 2 philanthropic organizations in Colorado, the Anxious Acceleration Initiative and the Anna and John J.C. Foundation, which of course is very related to the Global Down Syndrome Foundation. So N1, safety profile and clinical benefits, will continue to monitor for any adverse events that may be happening, but we also look at the health of these kids. And the prediction here is that if we can stop the autoimmune attack from happening in the first place, the kids on the JAK inhibitor will be healthier. They should end up having lower rates of thyroid disease, skin disease, celiac disease, and perhaps other things, right? M2 will focus on early neurodevelopment and neurological health. We'll look at cognition, motor function, language and social communication, and other aspects of neurological health. And then there'll be blood samples collected. We're going to be looking at all these data sets of the biology of Down syndrome listed here to see what is the effect of the medicine on the physiology, the biology of these children with Down syndrome. So the first in the series of trials will be 6 months, as I explained earlier, and there'll be 4 visits. Month 1 visit can be remote, can be done at home. So it's a screening visit to complete all the labs and make sure that the participant is good to go. If all the labs are in normal range, everything is good, the participant goes then into a baseline visit to provide the research blood draw and complete the cognitive measures. Then there is another blood draw. Again, this can be done remotely at home month 1, and then a visit at month 3, and then the endpoint visit where we monitor for potential benefits at month 6 with the various activities, okay? A multidimensional investigation of the effects of JAK inhibition in young children with Down syndrome. So if this goes well, then we'll start moving closer to what is called a phase 3 trial. What is a phase 3 trial? It's a trial that can lead to an approval, right? I should point out there are more than 10 JAK inhibitors approved globally. 2 of them, the one that we are using, tofacitinib, and 1 more, Rinvoq, are approved for kids 2 and older with arthritis. Tofacitinib will be the first JAK inhibitor to come off patent next year, at the end of next year. And this means that there may be now generic versions of these medicines, which would be cheaper, right? That would be good news. So conclusions, this is my penultimate slide. Dysregulation of the immune system can cause many health issues in Down syndrome. I think we're yet to understand what is all that the immune system can cause in Down syndrome. Therefore, we strongly believe that normalizing the immune system could improve the health and quality of life for a person with Down syndrome. And something that I love to highlight here is that this is a clear example of persons with Down syndrome helping all persons with Down syndrome through their participation in research, leading to discoveries that become then clinical trials. I had a credit slide. Oh, let me do the credits and then I'll go to the QR code. I want to thank. There's a lot of people. It's hard for me to put all the names in one slide. I'm the spokesperson, of a very large team, but I do want to take a moment to thank the program leaders at the Sydney Institute, Kelly, Angela, Matt, and Lindy, but again, many others, and the many funding agencies, both through NIH, but through the philanthropic organizations. And everything we do in collaboration with the Global Down Syndrome Foundation. So this QR code, the pediatric trial is not open for recruitment yet, but we're coming. I don't want to put a date yet, but soon. So if you scan this QR code, you will go into a webpage where you can give us your information. You can select which study you want to be interested in, and you can select the regression study, or you can select Mission 1, the pediatric JAK inhibition, or let us know what is it that you would like to know about. So when the trial is up and running, we'll be reaching out to the families. And with that, Bryn, I hope that we have time for questions and criticisms.
Oh, we do. Well, thank you so much, Marielle. Thank you, Dr. Espinosa. That was amazing. We've received many great questions, both in advance and in the chat today. As a reminder, if your question isn't answered today, we will make sure it's addressed in the next 3 to 4 weeks to our membership portal, and then send out an email letting you all know when that's available. Let's get started with, we have 2 questions from Marielle. Marielle, if you want to unmute yourself. Our first question for you is, why is research so important to you?
Yeah. Sorry, this is for Marielle or for me?
For Marielle.
Yeah, for me. Because I want to be happy and great to happy for the kids for Down syndrome. So you know that.
Research is important to you because you want to stay healthy so you can keep showing up and volunteering and help the kids in your aunt's class. It's awesome. And then what do you do to keep yourself healthy on a daily basis?
Oh yeah. Watching my washing my hands. And covering when it was cold and everything. So yeah.
Keeping yourself warm when it's cold outside and washing your hands. Those are both good answers. You also said you were a dancer, and that's probably good for your health too. So thank you, Marielle. I will
turn at all times.
Yes. Well, I'll turn now to Dr. Espinosa. We have a question here from Alan. Alan asked if interferons are known to play a role in Alzheimer's. Do JAK inhibitors cross the blood-brain barrier, and would that be an approach for the treatment of Alzheimer's with Down syndrome?
Great question. I love this question. So before I answer, let me make sure that we're all on the same page about Alzheimer's disease and why people with Down syndrome have more Alzheimer's disease. A foundational event in Alzheimer's disease is this accumulation of this protein called the amyloid protein in the brain, these clumps of protein. You can think like a little piece of boiled egg, right? When you boil an egg and you open an egg and you see all that white stuff, that's boiled protein. So imagine a little clump of that piling up in your brain. The reason people with Down syndrome have more of these plaques, which eventually leads to more Alzheimer's disease, is because the amyloid gene, it's called APP, amyloid precursor protein gene, is encoded on chromosome 21. So they have more of it. They have more amyloidosis. They have more accumulation of the amyloid plaques in the brain. Now, those amyloid plaques trigger an immune response, causing inflammation in the brain, also known as neuroinflammation. And that includes interferon signaling. Okay? So there is interferon hyperactivity around the plaques in the brain. In animal models, in mouse models of Alzheimer's disease, it's been shown that reducing interferon signaling helps, right? In that context, the neuroinflammation is bad. The inflammation in the brain contributes to the Alzheimer's disease pathology. So in this experiment, and there are many papers on this, if you tone down interferon signaling, if you get rid of those interferon receptors that people with Alzheimer's have more of, you slow down the progression of Alzheimer's disease. Now that is in the animal model. So how about Alzheimer's in actual people? Could JAK inhibitors be employed? Another JAK inhibitors that cross the blood-brain barrier? And the answer is JAK inhibitors have been proposed as therapies for Alzheimer's disease. And some of them cross the brain barrier. And some companies are developing JAK inhibitors that have better brain penetrance, right? So the person who has this, right on the money. We don't have a full answer yet. We don't know if JAK inhibitors will slow down the progression of Alzheimer's disease in Down syndrome, but it's a very sensical hypothesis that has some evidence in the literature.
Wonderful. It sounds like some exciting updates and breakthroughs, hopefully in the future. Why was tofacitinib, this is a question from Sarah, why was tofacitinib chosen over the other therapeutic options, over the other JAK inhibitors for the trial?
Great. So, this trial the protocol was written in 2019. And at the time, there were fewer JAK inhibitors available relative to today. And without going into all the technicalities of the science says that the best approach would be a JAK1 inhibitor. There's JAK1, there's JAK2, and there's JAK3. JAK1. And so tofacitinib is one of the JAK inhibitors that blocks JAK1. We were, at that time, I remember these conversations very clearly with the team. It came a head-to-head between tofacitinib and another one called baricitinib, that is a JAK1, JAK2 inhibitor. And without going into the technicalities, we thought that a JAK1, JAK3 inhibitor like tofacitinib would be safer. If you ask me the question today, I would say any FDA-approved JAK inhibitor that blocks JAK1, I think is a good idea in that syndrome. So I don't think it stops at tofacitinib. I mentioned Rinvoq, also known as upadacitinib, which is approved to an older for juvenile arthritis. That's a JAK1 specific inhibitor. We haven't used it, but from my understanding of inflammation in Down syndrome, that should be good as well. And there are others, right? So if they're FDA approved and if they block JAK1, I think they should work just as well. Yeah.
I've got a question from Jane in South Carolina, who said her daughter's 27 and suffered what she describes as a breakdown in 2016, and they think it could have been, and probably could have been, Down syndrome regression disorder. Her daughter is not a candidate for the trial. She's wondering, would immune therapy do anything at this point? And so I'm wondering, is there a limitation for when a regression was experienced and when someone can be enrolled in the trial? And then would this person be a candidate for immune therapy?
So, I cannot give medical advice and without knowing all the details, I'm not even sure if it is regression. But let's assume for a moment that it is regression, that it would meet the newly established diagnostic criteria. The longer that has passed between the regression episode and the treatment, the harder it may be to see a benefit. But we've seen benefits, Brain, of these immunotherapies for people who had regression for 10 years. So I think that nobody should give up. even if the regression happened a long, long time ago, it may still be responsive to treatment. We have many examples in the literature of long-term regression. Oftentimes that was treatment refractory, it didn't respond to this or didn't respond to that. And then, doctors found the right medicine and the participant came back. We have participants that went through 10 years of no memories, not remembering what happened. Now you talk to them and they're fine. So my recommendation would be to seek out a specialist in the area who is comfortable with the diagnostic criteria for regression. And, if the criteria are met, I think that yes, an immune therapy is a good idea.
It's a great point to reiterate, because I know some families may not be eligible for the trial criteria, but as Dr. Espinosa said, don't give up. There have been individuals who've come back after many years, and even if it's not 100%, they regain some skills and some function. So definitely talk to your doctors and providers and show them some of this research.
And I should point out, I want to answer the question more specifically. In the trial, we don't exclude based on how long the regression has been around. We don't. So the regression was last week or it was 10 years ago, we accept those participants.
Great. Okay. Could some of the cognitive effects and improvements that you were seeing in the individuals on the JAK inhibitor be related to better self-awareness because of, better self-awareness because of the hair growth? So I think this person is asking, maybe could some of the cognitive effects be due to maybe improved self-image or things like that? Maybe it's cognitive.
Yeah. So we saw improvements in what we call the anxiety and depression scores, and this is through surveys that the family completes. Those could be, that the person now feels better, having hair regrowth and all that. But I'm having a hard time understanding how that can help somebody memorize better on the CANTAB test, right? So yeah, maybe you feel less anxious, less depressed now that you have better self-image, but why they're remembering more on the test? And I should point out, that there's a lot of evidence about the harmful effects of inflammation on brain function. And people with alopecia areata in the general population have increased rates of psychiatric conditions. This is known. And when you see the skin acting up, say with alopecia, what you're seeing is an immune system that is acting up. And the first manifestation may be the skin, but you had to think maybe there's something else going on. Right? And the same has been true for atopic dermatitis. And this is in the general population. It's individuals with atopic dermatitis, higher rates of cognitive disorders and psychiatric conditions. So I think, yes, maybe self-image helps with anxiety, depression, and things, but also, yes, it is very likely that toning down inflammation improves neurological function more broadly.
Great. A question from Pat. Pat would like to know, are you taking new clients in the autoimmune studies? Are you recruiting for the autoimmune study? The
regression trial is open, and the pediatric trial is about to open. Now, the participant is older than 12 years old, they can reach out to us, and the skin trial closed, but we have other avenues to, if the participant has a skin condition, we have other avenues to pursue a JAK inhibitor there. We can connect the family with the right dermatologists and for them to define whether or not a JAK inhibitor would be a good idea.
So that's important. If you're interested in the skin autoimmune condition trial and your loved one is older than 12, is it, Dr. Espinosa? What's the pediatric upper limit?
2 to 12.
2 to 12. So 13 and older, do reach out still, because we can help connect you to the CERNIC team. They can help provide this research to your doctors to see if this would be appropriate for you, even though the condition is closed for, the clinical trial is closed for individuals older than 12. Let's see, we've got 5 more minutes here for questions. So we have, let's see. What are the common side effects of JAK inhibitors, and what are the likelihood of seeing these side effects?
Great. If you read the label of the approved JAK inhibitors, then these are immunosuppressant medicines. So the most common effects are upper respiratory infections. You may get rhinorrhea, cough. That's the most common, which is what we saw in our own trial. And then you start getting into the more rare events that have been documented. This could be the blood clots that I mentioned. In older adults with rheumatoid arthritis taking also methotrexate, which is another medicine, there was an uptick of cancer. This is in older adults, 50 years and older. So the medicine was compared to a different immune medicine, and cancer rates went from 2.5% to 3.2%. So there was a little uptick in cancer. But the main things that I would be looking out for are infections, right? That if you have an uncontrolled infection, if you can have uncontrolled herpes zoster or some other infectious agents, you should be mindful that the medicine is toning down your immune system. Now, we have an opportunity here in Down syndrome. Everything that I just told you brings in the general population, okay? In Down syndrome, we have the potential for a Goldilocks type of a scenario. I think that's the phrasing, where we can bring the immune system right down to the normal range without suppressing it, where we can get then the benefit without the side effects that have been documented in the general population. So we may be lucky here and be able to tone down the immune system without fully suppressing it, and therefore get benefit without the undesirable side effects.
Great. I have a two-part question from Razine. Can baricitinib be used instead of tofacitinib for alopecia and hypothyroidism? And then also in the trial, did participants with alopecia totalis see a regrowth of eyebrows and eyelashes as well?
Yeah. So baricitinib is a good medicine for alopecia. It's approved for alopecia. Yeah. So it's a JAK1/2 inhibitor, so I prefer the JAK1 inhibitors, but it's good. It's approved for alopecia. If that's what's available to the family, go for it. And yes, this hair grow everywhere. And we had when some of those participants that I said they didn't get hair regrowth, they got facial hair. So they didn't get their scalp growing, but they had now a mustache, some facial hair. So yes, the eyelashes and the eyebrows also come back.
Great. Can you explain, this is a question from Mary, can you explain why some people who participated in the clinical trials for JAK inhibitor did not respond well to the drug? Were there certain types of conditions that did not respond, Dr. Espinosa?
So for alopecia, we've seen a trend with how long the alopecia has been there. It's been alopecia totalis for 20 years, harder to treat, right? So I think it's related to how long it's been there, how much damage the immune system has done to those hair follicles. The condition that is the hardest to treat is hidradenitis suppurativa. But what we have learned in the course of this trial is that measuring improvement in hidradenitis suppurativa is very difficult. Hidradenitis suppurativa oscillates, fluctuates a lot. So you may have big boils today, and then next week it get better, and then 2 weeks later they get worse. So we're looking only at distinct points in time when we can see the person in person, and the families are telling us, the flares are less often and they are less severe, but we cannot capture, depending on when we're doing the visit. So I think that hidradenitis suppurativa, we need to look with more attention in more detail. Now, it is possible that some people with Down syndrome will not respond to this JAK inhibitor. Right? That the reason or the etiology of their alopecia areata or their hidradenitis suppurativa or the psoriasis is different than this interferon hyperactivity that I mentioned. There's more than one way of getting an autoimmune disorder. There's more than one way of getting chronic inflammation. So JAK inhibitors are a good idea for certain parts of the immune system, to tone down certain parts of the immune system, but there may be other medicines that will address other etiologies, the other mechanisms.
Well, this was wonderful. And again, we have received over 60 questions today. So we'll do our best we did our best to get through as many as we could. I'll hand it over to Sarah, who will wrap up, and we get those other questions answered for you.
Wonderful. Thank you so much, Bryn, Dr. Espinosa, Marielle, for spending your afternoon with us. And of course, all of you that logged on today as well. We greatly appreciate your support. As a reminder, if you're not already a member, we encourage you to visit our website and sign up. For only $20 per year. You get access to all 4 of the quarterly webinars and the Down Syndrome World magazine. One more time, we will do our best to get all of these questions answered quickly and put up onto our website in about 3 to 4 weeks, but an email will go out to everyone who registered when these items are available on our website. So thank you all so much. I hope you have a wonderful rest of your day. Bye.